So in this session, we are going to see a coal-based thermal power plant. So if you consider energy conversion process in thermal power plant, generally we'll be using fossil fuels for the power plants. The primary resources from the fossil fuels generally will be converted into mechanical energy to generate electricity. In power plants like hydroelectric plants, so we'll use potential energy of water to convert to mechanical energy and further to generate electricity. In non-conventional energy sources, so we use solar, wind, and geothermal energies to generate electricity. So in this session, we'll focus on heat energy from the fossil fuels, and how we obtain mechanical energy from this, and subsequently we generate power from this. So if you consider thermal power plant, generally we'll use boiler as the prominent device in the thermal power plant, which is used to generate steam in the water. So for that we use fossil fuels to extract heat energy from that. That heat energy is converted into mechanical energy, the heat energy available in the water. So that is in the form of steam. So that will be converted into mechanical energy when it is expanded in the device called a turbine. So turbine is a device which is used to expand the working fluids like steam or gases, and this heat energy is converted into mechanical energy by the turbine shaft, and in turn turbine shaft is connected to the electrical generator. So when the turbine shaft rotates, so it turns the electrical generator which produce electricity. So in this way, the heat energy available in the working fluid is converted into mechanical energy, and further it is converted into electricity in the case of your thermal power plants. So we are going to see various types of boilers which are used in the thermal power plants. So if we consider boilers, basically we can classify the boilers based on the steam pressure. Generally, boilers which are used in the thermal power plants will deliver with elevated pressure. So we call it as a high pressure boilers. So that would be more than 80 bar pressures. And if the pressure range is between 20 to 80 bar, then we'll call it as medium pressure boilers. And if it is quite low, between 15 to 20 bar, we'll call it as a low pressure boilers. This low and medium pressure boilers generally we'll be using it for industrial applications, and mostly we use high pressure boilers in the case of the thermal power plants, since we need a superheated steam which would be at the elevated pressure and temperature. And according to the circulation of water in the boiler tubes, will have a classification, namely natural circulation boiler and a forced circulation boiler. Natural circulation, so the water will be circulated through the tubes because of the density gradient due to the temperature gradient in the water. Post circulation, uh, we'll use a pump circulate water to the boiler tubes there. So conventionally we were using natural circulation. Nowadays we are using forced circulation boilers, so it should be more effective. And according to the flow of water and hot gases, uh, there are two types of boilers, namely fire tube boilers and water tube boilers. In the case of a fire tube boilers, the hot gases after combustion will be flowing through the tubes, and these tubes will be immersed in the water. In the case of a water tube boilers, the water will be flowing through the tubes, and the hot gases from the furnace will be flowing over the tubes. So some of the examples for the fire tube boilers, Cochrane, Lancaster, and locomotive boilers. And the examples of water tube boilers will have Babcock, Wilcox, and Stirling boilers. So this is the construction of Lemont boiler, which is a high pressure boiler, uh, which are being used in the thermal power plants. So generally, if you consider the boiler construction, the, the bottom of the boiler, you see that we'll have a combustion chamber. So where the fossil fuels, generally coal, will be burnt, and that hot gas is flowing from bottom side of the boiler to the top side, and we'll provide various heat transfer devices when the gas is flowing over those devices. Progressively, we'll extract heat from those hot gases so that the thermal energy or heat energy available in the gases are utilized finally to produce the steam. Uh, Seeing this arrangement here, so we'll have a provision to supply feed water from the hot well. So that would be supplied to the economizer. The economizer is a device which is used to preheat the water which is entering into the boiler. Preheating in the sense, generally if you see that economizer, water temperature will be around some 40-45 degrees Celsius, the entry temperature of water in the economizer. And we'll use the heat energy available in the hot gases to preheat the water. So we'll be heating up to around 80-85 degrees Celsius so that we enhance the economy of the uh, power plant by extracting heat energy from these hot gases. The preheated water enters into the steam separating drum. So already in the previous cycle, the the steam produced will be stored here, and in the steam separating drum, so we'll have the provision to separate steam and water. The steam which is coming at the top will be taken to the superheater, and the water which stays at the bottom will be taken and it will be supplied to the so-called radiant evaporator through the distributing heater there. So this in this radiant evaporator, the condition of working fluid is in the liquid state, that is water, and it enters here. So the water is converted into steam in the case of a radiant evaporator. The reason uh, the maximum heat energy, otherwise the high temperature gas is exposed to this radiant evaporator. So we use the word radiant evaporator. The reason the hot gases which is coming out from the combustion chamber, which will be around 1,100 degrees Celsius. This radiant evaporator is exposed to such a high temperature, so the radiation heat transfer will be predominant because the gas are at the elevated temperature. So there will be a radiation heat transfer. By means of this, the water is converted into steam. Very high heat transfer rate is possible in this radiant evaporator. So that's why we use the word radiant evaporator here. After that, the steam produced, generally it will be a dry steam. It will be supplied to the convective evaporator. In the case of a convective evaporator, the steam is further heated, so that will increase the temperature of the steam here. So we use the word convective evaporator here. So here when the where exhaust gas is passing through this convective evaporator here, the temperature is uh, relatively less when compared to the radiant evaporator here. So the radiation heat transfer is less here and the convection is predominant. So most of the heat is transferred from the hot gas to the evaporator tubes by means of convection. So that's why we use the word convective evaporator here. So the steam with high temperature is entering into the steam separating drum, and the steam leaving from this steam separating drum is entering into the superheater here. The superheater steam which is coming from the steam separating drum will be dry steam here, and we uh, further enhance the temperature of the steam by extracting heat from the hot gases which is flowing over the superheater tubes. So we increase the temperature of the steam here, so it becomes a superheated steam and it is further supplied to the prime mover. Prime mover is steam turbines where the steam will be expanded to produce mechanical energy, and in turn it drives the generator to produce electricity. And further, the steam uh, hot gases which is flowing over the superheated tubes is supplied to the economizer tubes where the feed water is preheated so that the thermal efficiency of the plant can be improved. And these hot gases which is passing over the air preheater. So air preheater is a device which is used to increase the temperature of air which is supplied to the combustion chamber. So when we take atmospheric air for the combustion, so generally it will be relatively low temperature. So increasing the temperature of air before supplying to the combustion chamber will increase the combustion efficiency. Subsequently, it will increase the overall efficiency of the plant. So the heat energy available in the hot gas is utilized to increase the uh, temperature of air which is supplied to the combustion chamber. And finally, the gases is leaving the atmosphere through exhaust gas. So in the case of a Benson boiler, the construction is almost similar to the Lemon boiler. So in the case of a Lemon boiler, so we use a steam separating drum. When we use a steam separating drum, so when the steam which is passing through the superheated tubes may be having a mixture of vapor and also water. So this may deter the flow path and also to some extent heat transfer it also. For avoiding sending of water molecules to the superheated tubes, so we eliminate steam separating drum. We ensure that only steam is supplied to the superheated tubes. So that is the modification. So that has been done in the case of a Benson boiler with respect to when we consider the Lemon boiler here. If you see the arrangement in the Benson boiler, so we'll have feed water, so that will be supplied to the economizer. So the water is preheated and it is supplied to the radiant evaporator. So in the radiant evaporator, so the heat from the hot gas is extracted. So the gas will be at the elevated temperature. So radiation heat transfer is taking place. So water is converted into the wet steam here. And then this wet steam is supplied to the convective evaporator where the heat energy is extracted from the hot gases which is flowing over the tubes. So the wet steam is converted into dry steam in the convective evaporator. The dry steam is supplied to the superheated tubes. So where the temperature of the steam is increased as well as the pressure. So the high pressure, high temperature steam is supplied to the steam turbines from the superheated tubes to drive the electrical generator. And the hot gases which is flowing over the economizer, which will be passing through the air preheater. So the air which is used for the combustion purpose will be preheated here to enhance the combustion efficiency of the plant. And finally, it is supplied to the atmosphere through the chimney. In the case of a Willox boiler, so we'll use a compressed air for the combustion, so that we can improve the efficiency of a combustion chamber there. So that is the main feature of this Willox boiler here. In the usual manner, we'll have a steam separator and other heat transfer equipments, namely economizer, superheater, and also we'll have air preheater. Considering this construction of this Willox boiler, so this is the combustion chamber, and we take atmospheric air and it is supplied to the air compressor The air compressor gets dry from the gas turbine unit, and this compressed air is supplied to the combustion chamber, and the fossil fuel is burnt. So the compressed air, it will be having higher density, then we increase the pressure there so that it can enhance the combustion efficiency. After burning the fuel, the fossil fuels here, the hot gases will be first flowing through these superheated tubes, and then it goes to the gas turbine unit where the gas will be expanded here. So the power obtained from the gas turbine unit is used to drive the air compressor. And then the gas is supplied to the economizer. So economizer has the provision to get feed water from the feed water tank. So the gases which is passing over the economizer tubes, which will be heating the water before entering into the boiler here. The preheated water enters the steam separator, and the steam which is at the top of the steam separator is supplied to the superheater. So the steam will be converted into superheated steam by enhancing its pressure and temperature. And it is supplied to the prime mover, that is for the steam turbine, for producing power. So the future of the Velox boiler is when you compare with your Lemont and Benson boiler, we use compressed air for the combustion chamber to enhance its thermal efficiency, subsequently overall efficiency of the plant. In the case of a Loeffler boiler, when you consider your Lemont, Benson, and Velox boiler, almost the steam produced in the boiler is utilized for producing power. But in the case of a Loeffler boiler, the arrangement is we utilize part of the steam for producing power, and the rest of this steam is utilized for heating the water. So around 65% of the steam produced in the boiler is used for heating the water, and rest of the steam will be used for power generation purpose. So considering the arrangement of this Loeffler boiler here, so we'll have the combustion chamber at the bottom of the boiler. It gets feed for fuel as well as air. So the combustion is taking place. That hot gases will be flowing to the convective superheater to transfer its heat to produce the superheated steam. After that, it goes to the steam heater. Then it goes to the economizer. And finally, through the air preheater and sent through the chimney to the atmosphere. So we'll in this the low floor boiler will have a evaporating drum. The steam which is coming from the the water, hot water which is coming from the hot well, which will be entering to the economizer. So it will be preheated and it is supplied to the evaporating drum. On the other side, uh, the superheated steam produced in the superheater. Part of the steam is taken and it is supplied to the evaporating drum. Through the mixing nozzles, it will be sprayed so that the heat energy available in the superheated steam is utilized. Heat the water. So we get steam from this evaporating drum. So that will be taken by a steam circulating pump and it will be supplied to the radiant superheater. So where very high heat transfer is taking place by radiation. After that, it goes to the convective superheater and then is applied to the high pressure turbine where the steam will be expanded. After expansion, the expanded steam will be supplied to the steam reheater. So we reheat the steam by using the heat available in the your hot gases. So we increase the enthalpy of the steam and further it is expanded in the low pressure turbine to produce the power. And the expanded steam is supplied to the condenser. So in the case of a low floor boiler, we expand the steam in two stages, as we call it as high pressure and low pressure stage. Where on the intermediate stage, we do the reheating process and we use part of the steam to produce the steam from the water in the operating drum. So it has been found that such arrangement has increased the thermal efficiency of the entire plant. It is all about the construction and arrangement of, and also the working of various types of high pressure boilers which are being used in the thermal power plants.